Everyone. In this video, we're going to talk about the binomial random variable. So the binomial random variable we'll get to in a minute, but it's an example, it's a specific instance of a discrete random variable, which is what we talked about last time. And actually, our first example here is going to be sort of a refresher on discrete random variables. So a multiple choice test has 5 choices for each question, and there's only one answer that is correct. There are 50 questions on this test. If you get a question correct, you get 2 points. If you miss the question, you get half a point taken off. And if you leave a question blank, you don't earn any points, but you also don't lose any points. We want to find the probability distribution for x, and we're defining x as the number of points earned on a question that we're going to guess at. So we're looking at one question that we're going to guess. Let's say maybe we answered 49 of the questions, but there's one question that I really don't know at all, and I have to guess. So our probability distribution for this question is going to have x, and it's going to have p of x. Again, x is are the values that the number of points earned on a question. So those are the possible values there. And so we can earn 2 points, or we can lose a half a point. Those are my 2 possibilities. I can earn 2 points, or I can lose half a point. Because if I don't answer the question, I'm not gaining points and not losing points. It doesn't really factor into the probability distribution here. Now, what's the probability that I get the question right? Well, there's one correct answer out of the 5 choices. So the probability that I get an answer correct and I earn those 2 points is 0.2. Again, looking at the formula, I'm taking the number of correct answers and dividing by the total number of choices that I have. If I get an answer wrong, well, that's going to be, there's 4 wrong answers out of the 5. So if I'm just guessing randomly, I have a 4 out of 5 chance of getting the answer wrong. Notice that when I add up my probabilities, they add up to 1. That always has to be true. So if you're calculating the probabilities and it's not summing up to 1, you are doing something wrong. You need to check that. So there's my probability distribution. I just answered part A here, and I found the probability distribution. Now the question here is guessing a good idea if you can't eliminate any responses? So really what this is asking is, am I going to average lost points if I guess? Or am I going to average gained points if I guess? So in order to answer this question, I need to find the mean of this probability distribution, which, if you remember, the mean, mu, the expected value, is the sum of all of our x times our p of x values. So I start by multiplying these 2 values. I can copy that formula down, and then I'm just going to sum that up, and that'll give me the mean of this distribution. And the mean came out to 0. So this is right here, this is mu. This is my expected value. Oop. So since our average value, our expected value is 0, that's the number of points that I would earn on a question that I guess at. So if I'm not gaining any points and I'm not losing any points, guessing is a good idea, yes. You should guess. It doesn't help, but also doesn't hurt your score. So now part C is a little bit different, because now we're being asked, if we can eliminate two of the responses, so let's say we're looking at the question and we know that two of the answers, we know those aren't right. That can't be right. So now we're down to 3 guesses. Is it worth guessing if there are 3 choices instead of 5? So we actually have to create a whole new probability distribution. We're going to gain 2 points or lose a half a point. But the probabilities are different. Because now if I'm guessing out of 3 choices, the probability that I get it right is 1 out of 3, which is larger than it was a minute ago, which means that the chance that I get it wrong is 2 out of 3. And again, these should sum up to give me 1, which they do. So if I find the expected value this time around by doing x times p of x, again, I'm just multiplying the value times the probability that value occurs. So I'm multiplying the value times the probability that value occurs, or I could just copy this down. And then I'm going to sum up these 2 probabilities. So this expected value comes out to be 0.33. So if you can eliminate 2 guesses, should you guess? Absolutely. You will average 0.33 extra points by guessing. Again, this is on a large scale. Now, does this mean that if you guess on one question, you're not going to lose points on it? Of course you might lose points on it, because you still have a 2 out of 3 chance that you're going to not get the question right. But if you're doing this 50, 100, 1,000 times, on average, you're either going to break even or you're going to gain points. Breaking even being if you can't eliminate any of the responses, or gaining some points if you can eliminate 2 responses. All right, so that's a little review of the discrete random variables and a probability distribution for discrete random variables. Let's talk about something new. So we're talking about binomial random variable. So here are the characteristics. And again, remember, this is a discrete random variable, but it's just a special type. And what characteristics can we look at to know whether our experiment is a binomial random variable or just a discrete random variable? Well, here they are. The first thing is that the experiment has to consist of n identical trials. There are only 2 possible outcomes for each trial. So I can either get them all right, or I can either have a success or I can have a failure. So there's only 2 possible outcomes. And success isn't always necessarily what humans would consider successful. A success is considered what the thing that we're looking for in the experiment. So the way that the problem is worded is going to determine what a success is. A failure is just everything else. So if it's not a success, it's a failure. The probability of S stays the same from trial to trial, which actually ties into number 4 here. The trials are independent. So remember the difference between independent events and dependent events. Dependent events will depend on the previous event, whereas independent events, it doesn't matter what happened previously, the events are independent and the probability stays the same. We're going to call the probability of a success P, and the probability of a failure is Q. So P is the probability of success, So this should read the probability of S is denoted by P, and the probability of F is denoted by Q, which is 1 minus P. It's the complement. So it's always true that P plus Q equals 1. That is always true. Again, the trials are independent. And number 5, the binomial random variable X is the number of S's in n trials. So we're always measuring X, our variable. Here it was which is the number of points earned on a question. And we could rephrase that. But in this case, X is always going to be the number of successes. That's how it's always going to be defined. Otherwise, we can't calculate the things that we're trying to calculate. All right, so let's look back at the first example and determine whether or not this is a binomial random variable. So it looks like we could define X as something different, like the number of questions we get correctly, or we get the question correct, and then the failure would be we don't get the question correct. But the way it's defined here, X is the number of points earned. And since we have multiple values that the points could be earned, plus the fact that there aren't n identical trials, we're just calculating for one guess, one problem that we're guessing at. This isn't asking, if I guessed on 50 questions, what's the probability that I get 30 questions correct? Now that would be something that's a binomial distribution, but the way that this is worded, it is not going to be binomial.